Hello, everyone. Good morning, good evening, depending upon where you are. Thank you all for joining. This is the continuation of the technology overview lecture series that we've been providing. Today's topic is 5G and beyond. Where are we? Meaning, how did we get here? What point are we in? And what is ahead, right? So what is coming up in the end? We will even touch upon 6G a little bit to give an idea of what is expected, what's coming up. I have said this in the previous lectures. I put these lectures together and give these to people outside Intel in universities, IEEE or ACM forums, things like that. So we include this disclaimer. I would urge and encourage all of you to consider doing such things outside Intel, because we do a lot of work and we bring in a lot of value to the society, and often it's not well understood by people outside. They generally think, okay, yeah, chips, yeah, they run faster, right? And maybe 5G, yeah, they go faster than 4G, and that's all the level of people's understanding. So it's our duty, it's our responsibility to go talk to the community to encourage them to understand what is it that we are doing. And in those lectures, I also talk about this networkbuilders.intel.com site that Intel maintains. So there are about 300 plus courses. When I say courses, they have like multiple little chapters, each one like an hour or two, provided by some subject matter expert with a small quiz at the end. And you can take a bunch of them to form a course and maybe form even some sort of expertise to complete a whole program. So that may be like 20 courses string together to make you give enough knowledge to make you an expert in, let's say, AI or ML, security or mobile technology, etc. This is completely free from Intel to anyone in the world, and it's not necessarily just to promote Intel technologies alone, right? So it is to encourage people to understand communication in general, and this should be accessible to anyone in the world. So you can just go to networkbuilders.intel.com. So check it out. You can provide feedback, and you can also encourage your contacts people to try it out. This is completely free from Intel side, but if people want some sort of a digital badge that they can attach to their LinkedIn profile, etc., then they can take the same courses via Coursera, and in the end, you pay a small fee, $50 or something. So you get a digital badge that you can attach to your profile as well, and that does cover 5G kind of topics in it, right? I do have some of my team members online, so if you have questions, you can post them. But what I'm presenting, since it's also intended for people outside Intel, it should be fairly easy for you all to follow. So we'll talk about what is 5G and what are the important technological domains, meaning how is it differing from 4G? Can we just say it's faster and that's about it? And like, what is the specific features that makes it different from 4G? How does it stand apart? What are the technical enablers that actually make this 5G idea work? Then business societal implications, and then we'll briefly talk about 6G also. Since it's remote, we'll do the question and answers in the end. There is a lot of material to cover, so this may go on for an hour or more than an hour, but I'll stay back to answer any questions. You are welcome to post them on the chat also, because I'm sure there are better experts on the call who can give you good answers or get the discussion going in parallel as well. So to step back and then give you a big view of where are we, what are we talking about? So you can generally think of mobile networks starting from the mobile devices point onwards. So this is maybe a cell phone or a tablet that you have that is connecting to either through Wi-Fi or like base station connects to the cell phone network. And that takes the traffic through backhaul connection to the core of the network. And then it's all like data traffic going to a data center and internet over there, right? And it's two-way. And as you know, the divisions that we were on and the products that we actually make, sell, a lot of NEX products go into this base station domain. So we have products like Snow Ridge or currently Grand Ridge. These are being used by telecom equipment developers, vendors. You can think of any big name that's out there. They use these products to develop boards that form the base station equipment, right? And beyond that, of course, we do have Xeons running the data centers and core networks all around. I guess that's somebody not on mute. Okay. So we do sell a lot of devices here as well. So the Intel Core CPU focus on the Xeon side is all here. The NEX focus is on the base station and up to the edge devices. I kind of left out mobile devices because even though we may have some presence there, of course, predominantly the actual mobile devices like a cell phone, etc., are mostly handled by our competitors or our customers on the other end, right? So we are talking about this range of products that Intel sells. And often when we talk about telco equipment, people tend to visualize it as some sort of a nice box sitting inside an air-conditioned data center. In some parts, that may be true, but in many situations, that is not really true. So these are cell tower equipment that were installed in Sweden. You can see how much it's all iced up. And then this is, I understand it's in Arizona. So it's in the middle of a desert, right? So as a result, we do need to make sure our chips, the equipment that our customers put together, work in a really wide range of temperature from minus 40 degree to 55 degree Celsius, not Fahrenheit. And this goes even beyond. If we go to really like industrial automation, IoTG kind of devices, we do get our chips tested to be working perfectly in up to like 105 degree Celsius, right? So it needs to work on extreme temperature and conditions. So we need to keep that these details in our mind, because if you always think it's a nice lab where things are working, that's easier to imagine and make things work compared to in these harsh environment. Why is it important? Simply because even though the chip may be working perfectly in the lab or in some reasonable temperature, even at 55 degree, if this goes to 100 degree kind of temperature inside an industrial situation, the board may warp, and so some pins may get disengaged, the soldering may become weak, and so the signal transmission may not be good. And these are really difficult problems for us to debug, right? Because it's not persistent, it comes and goes. And so the amount of effort our engineers put in, the products that Intel sells, it's actually spectacular. It's really wide ranging, not only covering different domains, but the effort that goes into ensure the stability with which they need to work is phenomenal. Right. So when you hear about 5G, we've been hearing this maybe for the last 5-10 years. And so we keep saying it's going to be forging new industries, it's going to improve lives and disrupting business models. So there may be a lot of marketing hype, but there is also a lot of energy and there is a lot of money getting invested. So it's not all false or purely marketing hype, right? So we'll dive into seeing how is this really changing? What is it that's new that may bring in new industries and change the society in certain ways? So let's dive into what is 5G. So to begin with, it's a large umbrella, right? So it's not one chip, it's not one particular factor, it's not one throughput capacity or one latency number or anything like that that defines 5G, but it's a broad set of parameters that need to come together. Naturally, it does provide higher speeds and greater capacity and lower latency. People have this level of understanding definitely, right? Yeah, compared to previous generation, we need to have a higher throughput and so forth. But how is it becoming possible? What's going on? That's what we are going to dig into in more detail. One significant difference from 4G to 5G, in addition to speeds and greater capacity, is it distributes intelligence throughout the network, right? For NEX, the edge is really big. So if you go 10, 20 years back, maybe a lot of things were happening only in the data center. And so the edge device, maybe a cell phone, in previous generation were just a terminal to give you the display of whatever that you need to look at, just a terminal device. It didn't have a lot of computing capacity and it wasn't required, right? So that's how the network was initially structured. But now we need a lot of things happening much faster close to the edge. And so we need to push some of the computing capacity towards the edge. And that's what makes 5G different and also gives us a big business opportunity to make our stand. It does meld the worlds of wireless, cloud, and computing. I'm sure you all understand that. I know I don't need to explain that much. So in general, simple pictures, crayon ideas help us cognitively perceive how things are evolving. So one way to look at it is 2G is some simple cellular communication that was taking place in the 90s, right? So think of 1991 to 2000 as the 2G communication era, and then 2001 to 10 as 3G, and then the 11 to 20 as 4G, and then 5G is now, right? 21 to 30 kind of time frame. So hopefully we'll have a 6G in the 31 to 40 kind of time frame. So in each one of these, there were definite technological changes, advances that came in, particularly because semiconductors made them possible, that were not simply possible in the previous generation, right? So if you look at 3G, that's when this data and app revolution took place. So we know the app store and then downloading app and installing it, and that was simply not possible in the 2G. The infrastructure didn't exist, the data capacity didn't exist. So this happened only in the 2001 to 10 time frame. And then from there, when we came to 4G, the faster data rates that we were able to bring in brought in so many possibilities and businesses that were simply not possible in 3G. So simple couple of examples would be, say, Uber, right? A business like that could not really work in 3G because the speed in which you can actually order a taxi cab and for that to be continuously shown second by second how soon it will be where you are, that wasn't really possible in the 3G generation. So similarly, even if you take some applications like Shazam, things like that, where you can use a cell phone, listen to a song that is playing in a mall, immediately recognize it and be able to purchase it and have it in your phone, that wasn't really possible in 3G. And so 4G made those kinds of things possible because of faster data rates. But when it comes to 5G, it's not only going to be faster data rates, but it's going to be reactive, smart, and connected devices. And we keep talking about IoTG stuff, a ton of them coming in. So this is going to make 5G much more different. So let's dive into some specific characteristics of what few things that makes 5G stand apart from 4G, and what is it making it now possible that was not possible in 4G. Okay? So before we dive into these broad areas, wanted to emphasize how important standardization work in mobile communication is. We are all engineers, so we know even if we design one of our own circuit, our own chip, our own some USB, Wi-Fi, SerDes, whatever it may be, just getting it to work in the lab, right? It's not easy. We have tons of engineering brains working on it day in and day out just to get the signals aligned and things to talk properly so that the input and the output match what we are expecting, and functionally we can prove that the device is doing what it's supposed to do. Now think in 5G, we want any given mobile set maker, irrespective of what the brand name is, talk to any cell tower that, irrespective of who's providing the service or like who made the equipment that run the cell tower, talk to each other, right? And then all this need to go all the way back to the other end, and then we should be able to make connections stable, things work, calls not dropped, and so forth. This is phenomenally, mind-bogglingly complex. And because of all the advancements that our whole industry brings in year after year, the general society has come to take it for granted, right? So they don't understand. They say, yeah, okay. I mean, I got instead of Samsung phone, I got Apple phone. Yeah, it looks a little differently. Or yeah, now it's much faster or something. But every little detail that's behind becomes possible because there is tons and tons of standards work that goes on in the background. And Intel is a big contributor. So 3GPP stands for Third Generation Partnership Project. So they have been putting out the mobile communication standards as release 14, 15, 16, 17, and so forth. The latest one for 5G, not 6G or anything, is still due in the next 3 months, right? In 2024 Q2. So the 5G work is not done. We are still working on it, still improving the standards, finalizing a lot of specs and so forth. Intel contributes a lot. Naturally, IEEE is a big contributor in this area as well. And so they have been providing a lot of standardization services. And from like Wi-Fi to so many other standards body, they periodically put out a lot of information that all the vendors need to agree on. And you can naturally imagine every one of the vendor is going to try to make an advantage for their position or their device or their technology. And so bringing everybody together to make these things work together is a Herculean task. And so we should give a lot of credit and understand the effort that goes into getting the standards established so that all these heterogeneous set of devices and equipment and services can all work together to provide a seamless experience to customers at the end. Right? So here, if you really dig into 5G, there'll be a lot of different individual areas that will pop out as, oh, this is so important, this is so important. So just to get our mind oriented, I'd like to think that there are 5 broad areas where roughly about 20% of the each effort goes in, right? So we will dig into each one of this. So the first one is massive MIMO. MIMO here stands for massive input, massive output. So that's basically the antenna technology that's being worked on to make 5G different from 4G. Second one is cognitive radio. The amount of intelligence that has gone in to make the radio technology better for 5G alone deserves hours of discussion and lecture, but we'll touch upon that. The low latency. It's easy to say, yeah, things work faster, right? But to make the low latency a reality is so much difficult. And this is where bringing a lot of edge technology to make as much computation or coordination, everything happen close to the edge becomes really important. And that low latency alone is going to make so many new either business opportunity or services or products that were not possible in 4G, possible in 5G, right? So we'll talk about that. And then this HD HetNet, so this high density heterogeneous network. So naturally, we can't rip off all the 4G stuff and put 5G in there because there is too much of investment that has already gone in. So how are you going to make 4G and 5G work together? And not only that, irrespective of who made the handset, irrespective of who is providing the cell phone or any other Wi-Fi service, irrespective of who is the vendor that sold the equipment that runs the cell tower, how are you going to make all this mesh together and still provide an easy connectivity and services that are flawless to the customers, right? So that's a huge thing. And then comes the collaborative computing, meaning things that were mostly done back at the network is now partially done at the edge, partially done at the individual terminal device itself. So you can even see this idea resonating with Intel's AI PC initiative. So instead of, I mean, till even 2-3 years back, if you say AI, we always thought of everything happening at some huge data center with a humongous computer. Now Intel is trying to bring that to the edge, right? So this collaborative computing, and of course, when we say AI PC, we are not cutting it off from the network completely. It's still going to talk to the network and get a lot of information. So this is another big thing that wasn't a big factor in the 4G design. Right? So we will dig into each one of this, but I hope you can remember these 5 factors, right? Massive MIMO, cognitive radio, low latency communication, HD HetNet, and then collaborative computing. So if somebody asks us, how is 5G different from 4G? This is how I explain. You can talk about these 5 aspects, and that makes people immediately realize, okay, and now I understand why 5G is better. It's not just like faster technology, but there is so much that goes into it, right? So let's dig into just the massive MIMO aspect first. So here, what we are seeing is the let's say a central cell tower. So if you look at any 4G cell tower, usually you will see 3 or 4 antenna elements, like cylindrical stuff that is mounted on. So they just broadcast the signal into the ether, right, into the atmosphere, just broadly, in the hope that whichever cell phone that needs to pick up the signal will be in that vicinity and pick up the signal and respond. Of course, that's the way things evolved, right? Radio communication, that is how it evolved. So that was okay. It got things working initially in 2G, 3G, 4G. But in 5G, we are expecting billions more devices to join the network. And in the 4G model, if you are really going to just broadcast the signal, it's very inefficient. If you really go in and look at the efficiency of how much power is spent in broadcasting the radio signal and how much is actually used, naturally you can imagine it just broadcasts into the air. Then there are only specks, dots of cell phones here and there picking up the signal and responding. So it's not even 0.1% of the energy that is spent is actually used for communication. It just gets wasted in the air, right? But if you are going to be supporting tons and orders of more devices, doing that model is not very efficient. In addition, we are also trying to transmit a lot more information, which means you need more reliable network. Maybe in 2G and 3G, it was just cell phone voice call for which the bandwidth requirement is really small. But if you're going to do a lot of data transmission, you really need a lot more bandwidth. And so if you're just going to broadcast everything, the efficiency is not going to be there, right? So that's why this beam forming technology came in. So imagine this is your cell phone, and then you are driving around in a car, and as you move from point A to B to C, the antenna element that is talking to you is going to keep switching from one to the next as you move. And of course, it can't just keep going. Maybe you'll stop here and make a U-turn, and so it should again go back. And so it will form small beams of information that just comes to your cell phone's location. So you are not wasting that much energy, and the reliability of the transmission becomes much more. As a result, you can transmit a lot more information quickly, right? Again, this may sound like an obvious next step to do, but I hope I'm giving you the sense of how difficult each one of this is, right? So as the device moves, imagine the amount of computing capacity you need to see how it is moving. And so from which antenna element to which antenna element the communication should switch, and then continue forming the beam, and then continue sending the information to the cell phone without any kind of interruption in the call or the service that you are receiving, right? This is tough. This is difficult, right? And of course, even if there is a little bit of latency, and as you move from element to element, the call cuts and starts, anything like that, of course, it won't work, right? So you need to make sure it's all extremely smooth, irrespective of whoever the vendor that sold the cell phone is. So this alone deserves multiple PhDs, a lot of work going on. I've spoken to vendors that are testing 1024 element structures using massive MIMO to beamforming to measure how quickly they can move from one element to the next, and how efficient the communication could be. right? So think of it as roughly 20% of the effort going on that front. The antenna, not just beamforming, but the antenna technology, cell tower, and the radio side on the on that. Then comes the cognitive radio. So in the previous versions, most of the things are hardwired, hard set. So you're not changing from minute to minute. You're not frequency hopping. You're not changing the like the spectrum from one to the next that easily in 4G or anything like that. So when we came to 5G, there were a lot of work that went into looking at all the spectrum that's available, and are we making good use of all the spectrum that's out there, right? So just to take a simple example, there may be radio spectrums allocated for military communication, right? I'm talking to you from Allentown, Pennsylvania. There is not a lot of military activity that's going on. This is not like really a border state or anything like that. So, but of course, there are places in the world where there is a lot of military activity going on, or there could even be a military base where there is a lot of training going on where they are using those spectrum. But because it's going on one corner of the world or one part of the country, not using the spectrum everywhere else is okay if you have enough spectrum. But now that we want to transmit a lot more information, we need more and more spectrum space. So there is a lot of discussion and standardization that went on, saying if you are in an area where some particular spectrum is not in use, 5G can use it, right? So things like even the TV spectrums that are unused in one part of the country, military spectrums not used, then they can be repurposed for 5G. But of course, if it's needed, we should be able to give it up also really quickly. So that flexibility, being able to grab a spectrum, use it, release it as quickly as possible, is a big intelligence that's brought into this cognitive radio aspect. So there is a radio environment, then there is a spectrum sensing, meaning what spectrum is actually being used, and then doing an analysis, then making decisions saying this is going to be used or not going to be used, and being able to switch back and forth. And then even unlicensed and licensed users. So let's say you are inside a factory and then you are using some network translation kind of thing, like a local private 5G network. What frequencies can you use? Do you need to go get licenses to use that? That becomes too cumbersome and complicated. So you think of it like 192, 168 XX IP addresses that we use, right? So something to that effect, ideas like that. Then the spectrum broker, which is to even assess whatever service A is requiring the spectrum and B is requiring the spectrum at the same time. So who gets priority, right? So that comes in. And then software-defined radio, meaning previously the radio head, the radio aspects were all mostly set in stone in hardware, and once you put it on, it just worked in one way. Now there is software going into that area so that it becomes flexible and you can change a lot of things. Again, I would like you to think in all this at the back end, the thread of while all this may sound very rational, logical things to do, see how complex this will be technologically to implement without creating any disruption to the service at the end, right? So there is a lot of effort that goes in. And the idea that 5G brings in is to actually carpet the entire area completely through the signal coverage, right? So with whatever signal that you can provide. So there could be this entrance base station that's like with a massive antenna, huge capacity, and so forth. So this can transmit, but you can see maybe there is like a hilly area in one end. Maybe there are it's like New York City, a lot of office buildings crisscrossing, so there is no clear line of sight. So in those situations, the equipment at the top of the building or the equipment on top of a house, they can communicate with the tower, and then they can provide a small area of coverage locally. It could be in a different even frequency spectrum. And so the devices nearby can just pick up and continue working. And if they really go into another area, they should be able to talk to the antenna directly, right? So on that, even the call handover, it need not be a phone call. Maybe you are watching a video on TikTok or YouTube. Even that should immediately get switched to the other device and continue having that service uninterrupted. And the idea even went up to the point of putting anything on individual lampposts. So with like solar panel, etc., so that you will basically have continuous signal coverage irrespective of where you are. You won't be in any shadow area where you lose signal, right? Are we there yet? Maybe not, but if you have used 3G and 4G cell phones, you can see the improvement that have come through. Maybe you are not having as many call drops now. Maybe the signal quality, the voice quality has become much better. That's because of not only the cell phone improvement, which is very visible right in front of us, but because of all these technological changes in the background as well, right? And these are all the spectrums that come into play. There is actually more. We don't need to go into each one of this, but I just wanted to give you a sense. So it differs from what service, like we said, military or TV or 5G space and those kinds of things. It also changes from country to country and different bands. And even within that, there are also different types of frequencies. So naturally, if you go into really high frequency spectrum, you can transmit a lot, right? A ton of data can be transmitted very quickly. But the problem with high frequency signal is the transmission is difficult. You transmit, it doesn't go too far, right? So it can go only little distances and you need repeaters or some sort of enhancement from there. Whereas if you come to lower frequencies, it can travel further, but it cannot carry a lot, right? And this has been taken into account in 5G design. So theoretically, let's say you are watching a Netflix movie, driving in a car as a passenger. And so as you just traverse through an area where there is like really high, massive, high frequency cell tower that's available, it can really dump a whole bunch of content onto your phone. So you can continue watching, it's buffered enough. And then as you traverse through leaner signal area, you don't get disconnected or the movie doesn't stop, right? These things actually get done. So there are attention paid to how the device is moving, in which direction, and where is the next signal handover, and is there going to be parts in between where we can improve the amount of data that is dumped to compensate for areas where it may not be enough. And of course, this is from the 5G side. There are, of course, other things go on the, let's say, YouTube or Netflix side, where each video is also stored in multiple resolution, right? And they constantly keep checking the connectivity and the bandwidth that you have. And as if you move from point A to B, where the amount of bandwidth reduces considerably, they'll quickly switch you over to a lower resolution video. And then when you come back to higher bandwidth capacity area, they'll switch you back to a higher quality video. So trying to keep you connected and not having to see the buffering thing that was very common years back, right? So there's a lot of thought and ideas that go in. So we don't need to remember each one of these bands, but just be aware that so many different bands, high frequency, low frequency, that all mix in to provide the best possible coverage for you wherever. And this one comes to that HD HetNet that we talked about. Naturally, it's high density, meaning compared to 3G or 4G, we are establishing a lot more transmission points. And I'm sure you heard about Intel Strata effort and like 5G private networks where we want to provide services within a factory, within a hospital, anything like that. So not depending on the public cell infrastructure that may be out there, but that increases the density. But on top of that, we also have these massive cell towers, smaller one, little servers. So we are spreading it all across geographically in space. so that anywhere and everywhere you always have connectivity available and accessible to you, right? So each one of this cognitive radio, visible light communication, line of sight, all this comes into play. And you need to take those into consideration to get whether it's wired link or a wireless link or whatever it may be, get things going without disrupting the service at any point, right? So the collaborative computing aspect, this should be easy for you to see. So as we were saying, this is why edge is becoming more and more important. So previously, if you imagine a 3G, 4G cell phone, the cell phone it had minimum computing capacity. And then whatever you did, everything was sent over to the network, things got processed and then brought back to you with the phone serving more like a terminal device, right? Whereas now even from a cell phone to a tablet with the AI PC coming in, a lot more computing capacity may be available at the Leaf node. And so we want to leverage it fully so that the experience can become more and more smooth and more services can also be offered. So if you do all these 5 things that we talked about, you end up getting a much better service, and that's kind of what defines or sets 5G apart from other services. And there are companies constantly working to improve this coverage. So next, we'll see just a short 1-minute video. These are all just on YouTube. You can just go check it out. So this one shows, let's say in situations where maybe in a university on the first day of registration, 30,000 students come in, right? Maybe hang around and maybe there is an orientation, something like that going on. But on subsequent days, the amount of traffic there may be a lot less. And I've heard companies working on, let's say in a cow pasture, suddenly on a weekend, there is a rock concert going on. So there are going to be 10,000 people coming in to attend the concert. There's a big stage. There are TV channels. They want to transmit to their stations. All the people there want to live stream stuff on Twitch and TikTok and YouTube. But 2 days later, the concert is over, everybody is gone, and so there is no capacity needed there. So in those situations, how do you provide 5G capacity has been a big thing. Even in case of disasters, right? So there is a forest fire or a flood going on. Suddenly you need capacity or an existing cell tower got knocked out. So there are designs where you have a drone-based temporary cell tower powered by solar panel that can be dispatched. You can put it on top of a building, and this can connect to a cell tower that's nearby to provide service locally for a limited amount of time, after which you can take it away, right? So I have a quick video. I have enabled sound also. If sound doesn't come through, one of you can shout and I can reshare, but hopefully this should work. Just a short video.
We're not getting sound, Sundar.
It should come now.
We get.
you can see the solar panels opening at the end, right? So that's pretty cool. So it doesn't need like wiring to get it powered up and so forth. Have one more clip that shows an actual flying base station. You can see how small things can get.
Hi, this is Ebrahim Boucheri from Lime Microsystems. There has been a lot of talk about small cell base station in recent years. We decided to take a design that is based on our first generation chip together with an Intel baseband solution. And this platform has been designed and implemented by one of our partners, Cambridge Consultants. And it's compact, low power, to the extent that we can install this on top of drones and have a flying network. These could have use cases in emergencies, in disaster areas, or developing world or rural areas.
Hello, I'm Danny Webster, Principal RF Design Engineer at Lime Microsystems, and this is a Ubuntu drone with a fully operational base station on top of this, and we're now going to try and make a call. Hello Ricardos, good weather.
There we have it. We are making calls through our own drone-based network.
So you can see, and of course, if it's a drone, battery powered, etc., it may look like, hey, it may not fly for too long, and what kind of service are you going to provide for like 10 minutes or 15 minutes? But you can imagine it's not really restricted to drone alone. If you can put it on a balloon, let it hang for hours. You can put it on a fixed wing aircraft that can fly around for hours. So let's say there is some forest fire and you want to provide communication to the firefighters out there. It may not be possible to provide permanent 5G cell tower that will be used just in the summer during forest fire season, right? So putting it on a balloon and then providing the service, that's fantastic. I mean, that really improves the connectivity and what you can achieve. So we've been talking about these multiple ideas. So let's just collect them together to see what techniques are actually enabling 5G. So we talked about antenna technology, standards work to get the consensus. There are this millimeter wave. So if you really go look it up, these are high frequency spectrum that in like few seconds you can download a movie, that sort of thing. Then 5G NR stands for new radio. And then the movable base stations that we just looked at, MEC, mobile or multi-edge communication that is trying to bring the latency down. Then SDN, the software-defined network, and NFV, network functional virtualization, that actually moves things wherever you want, right? So even if you need like a PC, a server that has to do XYZ, the network functional virtualization allows you to have the PC or the server at one location and then be able to move it around wherever it is needed at a given point. Then comes this URLLC that stands for ultra reliable low latency communication. So we'll see another quick video after this, then we'll talk about that. And just this LLC, that low latency communication alone, makes so many things possible that were not possible before, right? Then EMBB is enhanced mobile broadband. And then the MMTC stands for massive machine type communication, meaning IoTG, talking to each other and so forth. So you can see how many things have been folded in, everything on the kitchen sink, right? So to get 5G going. So let's look at how are like an easy way to illustrate the low latency communication. So this is just a fun video. It's a slightly longer video, but we'll watch it and then talk about why it's important.
Hey, I'm Bill Goodman, lead engineer from the Ericsson Technology team.
And I'm Dan Huffman, principal engineer from Verizon Wireless.
Our goal today is to push the limits of mobile 5G we're fundamentally advancing the technology that wireless consumers will use in the next decade and beyond.
Speed is key. We know we have to deliver the fastest 5G connection possible. Today, we're out here at the Indianapolis Motor Speedway to test our newest technology inside of a moving vehicle.
We're pushing beyond today's technology. With multi-gigabit speeds and super low latency, we're enabling new applications and the Internet of Things.
As our vehicles get smarter, our network also has to get smarter. And we're doing exactly that with a 5G network capable of pinpointing your device and maximizing your bandwidth at all times.
We're going to have some fun today.
But remember, all the results you see today are real.
Bill, you got a copy? Copy, Control. We're ready for our run. Let's do one for real. Whoa! What's wrong? Are you okay? All good.
Starting baseline speed test.
Copy that. Throughput looks great. Go ahead and start the downlink stream. The downlink stream looks great. Go ahead and start the uplink. All right, guys. We ready for the final test?
Okay, driver. Bring it back for the blackout test. Blackout test?
I don't remember any blackout test.
To really kind of push the envelope and showcase the low latency, we added in this virtual reality driving where we'll black out the windows. Virtual reality glasses will be worn by the driver, and the camera will take a feed and uplink through 5G into the network, turn around, send it back down over 5G, and do that quickly enough so that the driver can react appropriately as he's running around this track at speed.
Our way in.
I think it's safe to say both Verizon and Ericsson are very happy with the results we were able to achieve today. We were able to prove in a highly mobile environment that we could exceed speeds in excess of 6 gigabit down, all while maintaining extremely low latency.
We took a great step forward today, Dan. 5G is the future, and today the game changed. Next time you're in the car.
Just a fun video. People may ask, hey, why would you want to flap out the windscreen? But it is to just illustrate the low latency communication, right? So it cannot be more than few milliseconds because you may go crash the car somewhere, and it needs to be extremely reliable as well. So why are we doing it? What's the point of reducing the latency so much? This is what makes applications like remote surgery possible. You can go look up Da Vinci. That's one company that's making remote robot surgery equipment. So literally, the surgeon can be in one town, and the equipment can be in another town, and surgery can be performed that way, right? So again, if you ask why would you want to do that? Why can't they do it locally? Again, there could be a physical barrier, there could be a disaster, it could be a war zone because of which the surgeon may not be able to travel to the exact location. And 5G kind of technology makes such things possible, right? So you can see this idea repeating. Just the low latency alone, for it to work, we need to bring computing as close as possible to wherever things need to happen. If you say everything goes to some headquarters data center somewhere and then comes back, that low latency is not going to work. And are we seeing this difference right now? We are. So wherever I travel around in the world, I use my cell phone just to do a ping test to see how long it takes for me to get a ping reply back. So I used to get like up to 196, 200 millisecond, something like that in the years past, right? That is because when you create a ping, usually it's not the cell tower or something responding. It goes all the way back to the data center where some server recognizes that as a ping, and then it sends a reply back in older technology, right? Now we are moving that closer to the edge, so you get these replies much faster. You can see that time reducing. And naturally, if you're talking to a person on the other side of the earth, you can't reduce that latency. The signal needs to travel back and forth, but we are not talking about that. It is to be able to bring in services like maybe self-driving cars that need to crisscross the road. Currently, all the intersections are governed by traffic lights that are designed to allow human drivers to cross, right? So in the future, you can imagine the cars being able to talk to the network that are ultra reliable and low latency. So technically, in north-south, there could be a car crossing the intersection, and within a fraction of a second, another car could be crossing east-west without ever creating an accident condition, right, without hitting each other. That will be possible only if the cars, if the cell tower equipment and the network that is there locally makes it possible, and they all can talk to each other in a safe way in an ultra low latency model, so that the traffic intersection efficiency can be increased much more, right? And only then it will be possible in case of a surgeon getting the haptic feedback as they cut through tissue. You need to get that sense back to the surgeon so that they know what they are doing. Those things will become possible only if the latency is really brought down to low number and then made extremely reliable, right? So bring in proximity, bring in ultra low latency, increase the bandwidth, real-time access to radio network information. All this becomes cornerstones that needs to make 5G reliable. And only then things will really work. The new services can be provided. And again, this goes back to a lot of standards that need to work together. So just wanted to mention what are all the different areas in which standards organization keep working, right? So this is release 16 that came, I think, maybe 2 years back. Now we are at release 18. So V2X, that means vehicle to anything communication. So this is vehicle talking to your phone, or maybe one vehicle talking to another vehicle. These things were not flushed out 10 years back, right? It was not even really a concept or a notion at that time. But now these are getting flushed out. Then side linking, meaning without the cell tower coming into play, the cell network coming into play, other entities in the network being able to talk to each other. So maybe it's like one cell phone to the next, or maybe it's a cell phone to the car, or maybe a roadside equipment to the car, things like that. So that can happen. And there is a lot of work going on. So I was in UPenn a couple of years back, and there are actual, professors working on forklifts that are used in all the warehouses to pick up stuff and go put it somewhere else. Of course, you can design like a ultra high-end forklift that has all the technology built in to self-drive itself, but that's going to be 10 times more expensive. Eventually, it will come there and the prices need to come down. But they were taking existing forklift, just adding a cell phone capacity to it so that one operator using an iPad can actually drive 10 forklifts to keep moving stuff from one part of the warehouse to the other, right? So you basically say, okay, pick this up, it picks up and it automatically knows where to go. And this is all coordinated using private 5G network within the warehouse itself. So those kinds of network, that's all in play. Location services. So even this, so for example, the GPS is one thing, but for, right now, if you're not familiar with it, just check out the number 3 words. What 3 words? If you look that up, it's a technology that provides you converts the GPS coordinates, right? The latitude, longitude, within like a 3 meter by 3 meter square anywhere on Earth to 3 words. The 3 words could be very easily comprehensible, like for people to remember kind of word, book, computer, desk, or something like that, right? So book.computer.desk can be the address for a particular coordinate. So if you go to what 3 words, it can convert your location or any location in the world into 3 words. Why do we need this? Maybe you are in an area where it's not clearly, there is no address. Maybe you are in a national park and you ran into an accident, how do you give your coordinate to people like that, right? So this what three words kind of thing, you can think of it. I mean, I figured out what the what three word is for the front door of my house or the back door of my house, etc. You can give it to people and they can come to your home. So it could be useful in emergency situation. And these kinds of services are becoming part of the 5G services to provide very precise location services all over the world, right? And then extended reality, that is to enhance with like this Oculus Quest kind of thing, or maybe the Google Glass, which went away, but I'm sure it will come back in some other form or other, where we can add additional information to your vision, your field, what you are perceiving, hearing, so you can extend the reality. That's all becoming possible, right? So this is all great. And so is it all like hunky-dory? Everything is going fantastically well? Not really, right? So there are major stumbling blocks. Few things to mention is number one, no one wants to pay for it. So even you and I, we are all trained to pay, I don't know, $30, $40 per month for our cell phone services. So even if the phone company tells you, I'll give you ultra low latency, reliable communication, give me $100, we don't want it, right? So no one wants to pay for it. We want everything for the same $30 price forever, but we want the service to be improving. It's not our fault. In a way, it's our fault. Our industry has trained the society to expect more and more and more for the same price, right? So compare this to other areas like Big Pharma. Again, I don't have anything against Big Pharma. They do fantastic work. That's all great. But if you just look at hepatitis C, that's a disease. There is a company called, I think it's called Hormone. They came up with a pill. You take that for 40 days, the disease goes away. So no surgery, nothing, right? But the price for treating one person is $100,000, right? So can you imagine any service that we provide for which anybody would provide like $100,000 for one person kind of thing, right? So it's really impossible. Even though it may sound like they are saving lives, but we are also saving lives. So many things becomes possible only because our technology helps things possible, right? But it's not perceived that way. And because of Moore's law, because of the industry trend, people think more and more services should become available, but for the same price. So getting more money becomes really difficult. Not only that, and it's not a one simple one technology upgrade, right? You can't change one device, one cell tower, and then suddenly you have 5G. You saw how many things need to come together. There are more hurdles, but one solution that's being proposed is network slicing. We can talk about this alone for another hour, but the idea is to create multiple horizontal slices of the network where some level will have extremely high reliability, priority, low latency, etc. And then other levels will have less and less reliability or latency. And then you can sell these slices differently to different customers, right? So it's like somebody who just wants to watch a movie or look at read email, they'll be willing to pay the same $40 price. A little bit of here and there buffering, etc. is okay. They are just reading email. They are not even going to notice the delay that much. Whereas if somebody is doing robotic surgery, you really need extremely high latency. So these things can be, all the data can be flowing in the same network, but because of slicing, the different services get different priority, right? And then for the higher priority, you can potentially ask for more money, right? So that is one idea that's actually getting implemented. And so what happens because of that? This is just, I mean, my back of the envelope computation. So if you have for manufacturing kind of application, you need like 1 millisecond kind of latency. But for most other things, the 5G standard is more like 5 millisecond latency for remote surgery, etc. So if you take the speed of light, that's about 300 kilometers per millisecond. Since we are talking about round trip, need to go there and then come back. So maybe it makes it like 150 kilometer radius. So that 5 millisecond radius will actually give you about 750 kilometer or about 466 miles, right? Which means if you are doing surgery, the surgeon can be around 466 miles away from where the surgical equipment is, and he can still make this work, right? And 10 milliseconds for VR applications, virtual reality application. If it goes beyond that, you're going to feel like you are seasick. Your vision is not in sync with you, and it's not a good experience for people, right? So there are these different levels of latency that is described, and if we can make the slicing work to make sure these limits are met, you may be able to provide differentiated services to different customers using the same network, right? So that means strict net neutrality may not be possible all across. 10 years back, you can imagine, I mean, you might have heard net neutrality being a big discussion point, because at that time we were thinking the amount of network bandwidth is only that much, and if neutrality is not there, only some expensive or big corporate companies are going to grab all the network and others are not going to have any at all. But you can see with 5G, we have really expanded the amount of network capacity. And so not many people are talking about network neutrality now. But in addition, you can also do this slicing to be able to provide different levels of service to different customers, right? So that is more efficient spectrum use. That means you are using less spectrum to provide a service, and then you are sharing the spectrum. And so that can potentially increase the dollar per spectrum unit. So that's a way to squeeze more dollar out of existing infrastructure without having to squeeze the individual cell phone owner to pay more, right? There is also this greenfield, brownfield issue that we talked about, meaning we are not going to report all 4G and then put 5G. So the brownfield, meaning there are existing technology and 5G needs to work on top of it. Whereas if it's a greenfield, there is no deployment before, and so you can do a lot more things more efficiently, right? And many use cases will also require social acceptance. So there is just one thing that I can mention. So you might have heard about this trolley problem. This becomes a reality. So I actually wrote one book called Thought Experiments that talks about this and many other related ethical dilemma. So we won't go into a lot of detail. You can buy the book. Again, I'm not making any money off of it. All the money goes to charity. But the idea here is there is a train track and there is an unmoved trolley or a train that's like rolling down. There are 5 people working here, and if you don't do anything, the train is going to mow them all down and kill them, right? So you are standing here and you have a lever. If you just pull the lever, the train will be redirected to the adjacent track where there is just one person working, and that person will be killed. The question is, will you pull the lever or you won't, right? Most people in the world, irrespective of whether they are rich or poor, which religion they belong to, what country, they all say, yes, I'll pull the lever. I want to save at least 4 lives. So only one person getting killed instead of 5 here, right? So that sounds logical, rational. But if you just change the thing to say, instead of a lever, you are standing here, and then there is another person standing next to you, and you can push this person down from the bridge. He'll fall into the train track, and again the train will kill him, and then the train will stop, and you will still save these 5 people, right? If you say this, most people somehow feel queasy. They don't feel comfortable pushing this person down. This was originally introduced as a moral dilemma question. The explanation given here is, in this case, the train is definitely going to kill people, and by moving this lever, you are just reducing the kill count, right? So people are comfortable. Whereas here, this person is not really in the scene at all. He was not going to be killed in any way, but you are pushing that person down, so that makes people uncomfortable. And why are we talking about it? This was originally introduced as a moral dilemma question, but now the self-driving cars can be completely programmed to say, when you are driving down, if there is a person on the road, what do you do? right? Currently, it depends on the individual driver's reflex, how fast you are going, how good the person vision is, and so forth. But if you program it on the algorithm, it's going to do exactly the same thing all the time. So even imagine instead of 5 and 1, so forth, instead of coming here, if you should you change so that you may end up hitting one person going on the pedestrian walk to save 5 people. Is that right or wrong? I mean, this person didn't do anything wrong, but if you even simplify this, let's say a person is jaywalking here, you are coming here, the car notices. So should the car really brake hard to save that person, even if the passenger inside who paid for the car is going to lose a couple of his teeth, right? So how do you evaluate? The car company may say, hey, this person is jaywalking. Our responsibility lies with the passenger who bought the car. We need to protect that person first than the other one, right? Currently, these are not questions, and but 5G and the new technologies that are coming in, if you are starting to work on these issues need to be sorted out, right? So this is just one example. There are a lot of other things that we can talk about that need to be socially accepted. So if you are here, what is beyond this? What is coming next, right? So moving to 6G, there are serious standards development haven't really started for 6G because, as we said, even the 5G work is not fully done yet. We are still waiting for standards update and so forth. And so if somebody says, oh, we have already implemented 6G or it's coming out next year, that's not quite right. But as we said, there is no one technology, one solution, one standard that says, okay, this is done, that is starting, etc. So it's a little fluid at this time. So we generally expect work to start only at the later half of this decade, and then if the same cadence, similar to Moore's law, if you are sticking to 1 decade per generation, if you maintain that cadence, that should come only next decade, right? So the 5G adoption even now is only about 40% in 2023, and then by 2030 it's supposed to near like 91%. So beyond that, only then 6G may come in. But there is a lot of competition that is going to go on for sure, similar to 5G, right? So China, under the China Dreams program, have actually launched this Long March rockets even in 2020 that are claimed to be 6G compatible. So there'll be push from different countries and companies to plant their flags saying, oh, we are here first, kind of thing. But it's still pretty early, right? And then spectrum allocation, the open RAN adoption, those are all things that need to be really discussed and agreed upon before we can really talk about 6G deployment, even in the next generation. But beyond that, what is it that we are expecting? What more can happen beyond this, right? So is it going to be, again, maybe reduce latency even more and then provide even more bandwidth? What will we use for? The answers actually start to differ. So one idea is to unify the physical, digital, and then human world. Physical and digital, we understand. By human world, we mean our own body, metabolism, blood pressure or sugar or pulse, heart rate, anything that you can imagine. So combine all this to provide a much more seamless experience and world to people, right? So that is one thing that's being thought of. And an extension of that is this digital twin idea, where I mean, right now, if you are going on vacation, we just set out of office in our Outlook, but think of it increased, I mean, like amplified 100,000 times, right? So there will be a digital twin version of Sundar in the network, and that version can actually do job interviews or sign contracts and so forth. So how do we implement with a lot of massive AI capability coming in, new kind of network architecture, and a lot more trusted computing? How do you make sure this is really representing you, right? So we don't have answers for these at this time. But if these things evolve, then potentially you can see a lot more new ideas, technology coming in that can relieve us of a lot of drudgery. So the digital twin can even go do interviews on your behalf, get you a nicer job in another section of Intel, etc. All that is really possible. So we don't need to do stuff that we don't want to do, right? Then all kinds of new IoT devices. We know currently from washing machine to fridge, it's all getting connected. But what else? Maybe sensors, body monitoring, etc. How do you still make it all trusted so that the information is not misused or violated? And then sensing the network itself, meaning the devices and the network becoming aware of what are all the things that are out there nearby, and so what is it that can be optimized. So these are areas in which ideas have started flowing in. If you go look at it, I think this is Nokia's idea, 6 key technologies for 6G. So new spectrum, naturally. AI ML is definitely going to be there. Network as a sensor, more connectivity, cognitive, automated, specialized architecture, security, and trust, right? So you can see I've distilled it down to just 4, but these ideas are floating around to make it much more possible, right? So we come to sort of the end of the lecture. So just wanted to finish with this thought. So some 3-4 years back, I was going around US and the world to provide these Snow Ridge demos all over. So this is a picture taken when our previous CEO, Bob Schwan, was in Barcelona in Mobile World Congress. At that time, I was standing there providing Snow Ridge demo, and one gentleman from Poland, he's a developer, he came by and said, this is all great, but do you really think we are bringing value to everybody in the world? Or is it all like some rich people thing, right? So I was thinking about it, and very interestingly, right across our booth, there was a Cisco booth that was running this small 30-second commercial that I'll show you next. That shows how this technology are actually transforming lives all around. It may be a company commercial, but the numbers are all true, right? And since I am originally from India, each year I go to India, I can really see how things are changing there. And so this next one, I think, gives us an idea of how lives are getting transformed around the world with these technologies. Let me play this.
India is all about bazaars. These small mom and pop stores, we thought about starting shop clothes to bring all of these bazaars online.
Handicrafts are a part of my tradition. When I started my business, the middleman would take all the credit. That's when I decided to put my name on the products.
The time had come to build a large company, but it took way longer. And then Jio came in, and then it just took off.
I now have a Jio phone. My products are sold in 20 countries outside of India.
Suddenly, women have access to their own device. 20% of our 600,000 merchants used to be women. Now, about 40% is women.
My dream is that the daughters in my community match stride for stride and walk shoulder to shoulder with the rest of the world.
Between a dream for India and a new reality, there's a bridge. Cisco, the bridge to possible.
That was my last slide. I am also aware of all the negative things that can go on with endless connectivity technology, and I do give a talk titled Ethics and Emerging Technology on the negative impacts and what is it that we should do to balance it out. So that's another thing. But if you notice that number, India's rank was 155. From there, it's jumped up to 1. And it's not just some bulk data usage in one corner or something like that. Right now, if you go there, a lot more than in US or other parts of the world that I have seen. There are QR codes used to do all kinds of payments all the time, even from some small vegetable vendor on a cart on the side from there, right? So it does transform lives, and Intel does play a big part of it all over, right from data center to edge to the individual mobile devices, right? So I'll stop there. Hope you found it useful and interesting. I'd take any questions if you have. Thank you. There were a lot of things typed on the chat, so great. There are no questions. Thank you for your time. I appreciate it. And then I'll go through the chat messages and then try to get back to you all. Thank you again. Bye-bye.